Hi, in this video we are going to talk about bandpass filter for AM signal reception. The process of making an AM transmission implies that a signal must be modulated in both amplitude and intensity to be able to be sent through the air at a certain frequency. And when it reaches the receiver, it is seen as an input signal that brings information sinusoidally. It is here where we witness the use of a bandpass filter. Upon receiving the signal at a certain frequency and combining a low-pass filter and a high-pass filter so that the signal is maintained at a certain frequency.
The modulation of radio waves can be given in FM or AM, with the difference that in AM, the amplitude of the signal is modulated. So, they are susceptible to alterations in the magnitude of the carrier as electromagnetic fields produced by external sources close to the receiver. While in FM, the frequency of the signal is modulated, so they wouldn't suffer changes like in AM. Rather, there are usually frequency overmodulations mounting one frequency over another, generating interference.
The behavior of a bandpass filter is only pass components at frequencies within particular band. Any component at a frequency outside this band is rejected. It can also be called a band selection filter, since it selects a specific frequency range to pass a signal without dimming.
Bandpass filters isolate a band of wavelengths from the total spectrum by providing a band of high transmission and bands of high rejection of spectral energy on both the long and short wavelength sides of the transmission band. These optical filters are defined by cut-on and cut-off slopes, establishing the transition between high rejection and high transmission.
The selectivity is defined as the measure of the performance of a radio receiver to respond only to the concerned frequencies is tuned to, and reject all other signals nearby in frequency. The selectivity in a bandpass filter is determined by the quality factor Q of bandpass filter. The higher the quality factor, the level of attenuation is higher in the stop band and bandwidth becomes narrow. Thus, selectivity is improved.
The relation between Q and bandwidth of a bandpass filter, Q is equal to F sub 0 divided by BW, where Q is the quality factor of a bandpass filter. F sub 0 is equal to the center frequency of a bandpass filter, and BW means the bandwidth of a bandpass.